Hey, what's up, everyone? This is episode 18 of the Morey Miles Show. Really excited to be able to release this for you. This is going to be a excellent podcast about the Azide performance. This is going to be an app that you could use to get some really great technical data when it comes to your sprinting mechanics, running mechanics, and the founder, Jack Puccini, sat down and talked a lot about the different parts of sprinting, and it just should be very insightful when it comes to better understanding what are some key points, some key variables when it comes to sprinting, but also get a little bit more information about the technology itself, and yeah, just be able to help you out and see some of the other technologies that are out there that can help you in improving your speed. So we'll go ahead and get right into it. So Jack, main thing that, to get started here, I would like to know more about, obviously, is just like the technology, how it got started, some of your background.
Yeah, absolutely. So probably the best way to frame the technology, I mean, the technology really came out from my own journey in sprinting and athletic performance. I was kind of I guess, late to the game compared to most people. I didn't sprint in high school or university or college or anything like that. I played sports when I was younger, but not track and field or athletics, as we call it kind of in Australia sometimes. But around maybe 3-4 years ago, I started getting into it, and I can't actually remember why. I try and remember what exactly caused me to take an interest in sprinting. Maybe it was I think I watched some finals at the Olympics or something like that, and I just thought it was really cool. And so I started getting into myself on trying to just get faster. And I remember I think this is probably a common experience of people getting in. They want to benchmark them or find out what the benchmarks are and compare themselves to where they stand. And so I was trying to time my 40-yard dash and stuff like this. And I remember I started out, I think, using my phone, and there's some apps you can download to basically mark points on a video and use that to calculate, what your times are, split times and stuff like that. But at some stage, I was getting more invested, and I wanted to have a proper system, so to speak, to find out what my real times were. I'd bought spikes, and I'd started training, and I was learning up on all of kind of the background theory and information, and recording myself to kind of critique my form, and posting videos of myself online to get other people's feedback on my form and stuff like that. And so I went looking for other systems, and I came across the Freelap system, which is a well-known kind of system in the field. But as someone that was kind of new to the field, I was kind of a little bit surprised by how much you have to invest to be able to get your times. But I basically just kind of accepted it, and I was okay, this is just how it is. That's just sprinting's obviously a very kind of, you have to be very accurate, and knowing your times to tenth of a millisecond or tenth of a second rather, and things like this are very important. So that's how it is. So I ended up buying that system and timing myself and whatnot, and I didn't really think of anything of it. But it was actually when I was talking to my friends, my soccer friends and stuff like that, I was telling them, I'm getting into sprinting and all that, and I was saying how I time myself and all of that, and they're oh, why do you spend that much money? You could make something that does something like that. And at some, I was no, that's just how it is. It has to be very precise and whatnot. But it was actually my friend that told it to me. And from then I started to think maybe I could. I mean, me and him were both technical people. We studied engineering and science and stuff at university. And so that's when I thought maybe I can make a timing system. And so that's when I started trying to make a timing system. It didn't start out what it is now, which is the Sprint Vision kind of visual system. I started making my own timing gates, laser gate timing system. And I did make kind of a prototype of that. I could use it for my own benefits, or for my own testing at least. There was already so many different timing systems out there that basically give you your split times, and there's so much more involved in sprint performance, so many more metrics and insights that are valuable when assessing your own sprint performance and critiquing yourself and whatnot, that you can't really get. And so I started thinking about other systems. I experimented with a pulley type system, the 1080. You might might be the closest comparison. The 1080, I thought if I was ever going to bring something like this to market, it would be quite difficult with the technical complexity of the product. It'd also have to be quite expensive, and there was also some other technical things. So when I came across technology that really forms the basis of the Sprint Vision software, which is basically computer vision and what's known as pose estimation, that's when I kind of moved away from more of hardware, physical devices that people use, to more of a software approach. So I realized it could be much more easily distributed. People can just use it through the internet, basically through like cloud technology and whatnot. And also added benefit is it gives you access to all of these things that I knew were important because I was like studying sprint biomechanics and whatnot for my own personal reasons and learning how sprint mechanics works and what ideal sprint mechanics look like. I was kind of familiar with all of these things that are necessary to have access to when trying to improve your sprint performance, that weren't really available through kind of the things that I'd previously been building. I mean, you can get them if you annotate videos and whatnot, but it's not really kind of automatically provided to you. And so like this, that's when I came across this pose estimation technology. I kind of realized that through that, you can actually build a really great system that kind of allows you to give a bunch of different metrics that are important for analyzing sprint performance, past just like velocity, past split times, and all of that type of stuff. So that's when I started to create that. I've been testing it and building it and improving it ever since. And that's kind of like my journey through getting into sprinting and trying to basically come up with a good solution to analyzing sprint performance.
And so how does it all work in terms of the video? So you go, you set it all up. Is there like a certain amount of frames per second that you need? And, you know, with that, is it just like something you just can use with a normal, you know, camera app? And, you know, what's kind of the process through everything?
Yeah, so basically, for people that might not be familiar, basically how it works is you take a video of yourself or your athlete sprinting, and there are some requirements. So you need to be recording at 4K quality and 60 frames per second. And so these settings are available on most modern smartphones. On the kind of dashboard, the Sprint Vision Azide Performance dashboard, it has a list of different devices for different brands that would satisfy these requirements. But it's pretty easy. If you just Google it, you can see if your smartphone or device or whatever you're using is capable of recording at those settings. And you need the camera to be stationary. So a lot of people, when they're filming, they kind of, as the athlete runs, they pan across. That's not allowed. So it has to be stationary. So it's using something like a tripod or something like that is recommended to keep it stationary, because using your hands, you might move a little bit. And there's also other recommendations, like you want it to be a well-lit environment. You don't want the athlete to be super, super far away from the camera and stuff like this, but it's pretty flexible. And once you have that video, you basically just crop it appropriately. So that's not like a minute long. You only have the parts where the athlete's actually sprinting, although if it's an acceleration, right before they start the sprint, you upload it to the system. And basically how the system works, I think it's a bit kind of mysterious how it just takes this video and it generates all of these things. But I think by understanding like how the kind of base technology works, it's much more understandable how it works, which is basically it looks at, so I mentioned a couple times, this technology called pose estimation, which is in the field of AI or specifically computer vision. And basically what it does is it looks at each frame in the video and it can predict where the different landmarks, which are basically just the key points on the person, like the left knee, the right hip, you know, the left shoulder, all these points, can predict where those are in the frame. And so by basically going through the video and looking at the person in each frame of the video, we're able to determine where each key landmark is throughout the video. And so you're able to track, you know, the movement of the left knee, the movement of the right knee, and all of the landmarks. And so by analyzing that data, you know, you're able to calculate things like, you know, shin angle upon ground contact and the position of the center of mass. And once you know the position of the center of mass throughout the frames, you can calculate the velocity of the center of mass throughout the sprint by using the frame rate, because you know that, you know, 60 frames per second is like around 16 milliseconds per frame or so. And so by basically knowing the key positions of the person throughout the video, you're able to calculate all of these metrics. Now, I will say also, if you're going to calculate that, there's two different types of kind of reports that can be generated. One is a kind of full report, which is a comprehensive overview. It includes basically distance-based measurements. So it includes things like velocity, split times, and things like that. If you do that, there are a couple additional steps to kind of calibrate the environment to know exactly, you know, how far the person's traveling in real life, as opposed to knowing how far, you know, how many pixels their left knee has traveled between the two frames. There is an extra like calibration step there, but there's also these reports are called light reports, which don't require any calibration. They they can be processed basically instantly. So you upload the video footage and with a couple minutes, you get your report back. Those don't contain the distance-based measurements, but still contains a lot of useful data like ground contact times, flight times, body angles like shin angles and stuff like this. So every kind of sprint performance has to be analyzed through just things like ground contact times. And if you want to go that far, you can annotate the video and maybe get some angles like that, but it can only be analyzed through the lens of the metrics that you actually have access to. But if you know the position of every single, well, the main points of I think there's like 32 or so of the body at every frame, that just like opens up the door to kind of new ways to analyze in terms of different angles and translating those angles and the speed of these, of different limbs and whatnot into different insights like you were talking to. I think there's a lot of room for like interpretation and coming up with new ways to analyze this data, because I think it is like relatively new, unless you were using a really kind of expensive motion capture type system with the reflectors and all that type of stuff beforehand.
Yeah.
You're able to get access to that type of stuff. And you also can overlay that with the velocity, for example, the instantaneous velocity data. You have kind of this typical pattern of acceleration and then deceleration over each step, and comparing that to certain angles and like kind of doing analysis between that and certain angles and coming up. There's just a lot of room for analysis and interpretation here. So I've been thinking about that a bit recently, and I'm sure coaches and other interested people will be able to come up with their own ways to analyze this like data, given that you can have so much more like a rich data nowadays.
Yeah. And I mean, that's the big thing to me that caught my eye just is like, it's very different in terms of the information that you're going to be getting and how fast does it all happen? You know, so if I go in and I record myself sprinting, how much time would it take from that sprint to be done? I'm assuming it's all through your own app, right?
Yeah. So basically you take the video and then you upload it, and all the light reports, so those are the ones, just as a reminder, they don't have any calibration. It doesn't give any distance-based measurements, but it gives things like ground contact times, angles, and whatnot. At the moment, that one can be analyzed instantly. Like by instantly, I mean like a couple minutes. So you upload it has like a loading thing, and once it loads in a couple minutes, you're able to get all the data there. For the full reports, at the moment, they take up to like 48 hours to process. Since we're in the kind of beginning stages, we're processing them more slowly and basically not trying to frustrate people by making it instant, but then having some maybe errors when the results come back. But in the near future, both of them will be able to be generated within like minutes, basically. So you upload it and the processing done generates all of the feedback images, does all of the calculations with respect to angles, where all of the key landmarks are throughout the video, and gives back the full kind of comprehensive report within a couple minutes. But at the moment, light reports within a couple minutes, full reports 24 to 48 hours kind of turn around there.
Yeah, and with the information, I mean, what have you used, I guess, to help you improve the most, right? Like, what have you seen, you know, is like a part of it where it's like, okay, this helped me for contact time, you know, I guess overstriding, that sounds like two big things. You know, is there something in particular where you're like, you know, once I started getting this data and started really understanding it, it really helped me improve my own technique or my own sprinting?
Yeah, so in my own sprinting, coming back to like me personally, I mostly focus on acceleration, mainly because, well, I think I'm better at acceleration than top speed, so it's nicer to kind of focus on that. But also because mainly I play soccer, so kind of I'm a soccer player, and like within that, acceleration is generally like a little bit more important than top speed, generally speaking, with most of the kind of short, intense sprints happening under 20 meters. And so I usually try and focus a bit more on acceleration. I mean, I still do top speed. It's obviously got various benefits as well, for just overall athletic performance and, of course, for soccer players as well. But I mainly focus on acceleration, and that's kind of the main thing that I've been struggling recently with is overstriding. And I think that that's kind of a fundamental problem of acceleration, in the sense that fundamentally sprinting is about moving horizontally, and you're only going to do that, you know, according to the rules of motion, you know, F equals ma and stuff like this, when you're applying force in the backwards horizontal direction. And you can only do this when you're in contact with the ground. And so I kind of find everything, I mean, there's some nuance here, but I find it kind of funnels down to this concept, this base concept, how you're striking the ground, how you're applying force to the ground, and how that force is ultimately directed. And so overstriding for me is like one of the biggest problems at least for me, but I personally think for a lot of sprinters when it comes to acceleration mechanics. And so
That's
that's
so funny. I'm sorry to interrupt you, but I had this super long argument with somebody on like Instagram, and the whole thing, his whole premise of the argument was that you don't overstride in acceleration. Like you can't overstride in acceleration. That overstriding only happens at top speed. And it was just like the most, it was a funny, I mean, I'm laughing at it now. It was like kind of this back and forth, and it made me, because of how adamant he was, it made me kind of second guess, like maybe you can only overstride at top speed, because not a lot of, people usually talk about reaching more at the beginning. But, I'm glad that you're saying this, because it just confirms that overstriding is, at least what I've seen, it ends up being such a killer because of and I'm sure you're kind of getting to it, the shin angle, right? Because if that shin angle is vertical at foot strike, when you're accelerating, there's no way you can actually effectively accelerate well. Or, if you do, your foot contact time is so bad that ultimately you're going to end up not having great top speed.
It'd be interesting to hear what that guy was saying and how he was so confident about it, because I mean, it comes down to really how you just define overstriding. Maybe he had some sort of other conceptualization of what it meant, but for sure, I mean, it's a thing. Like the shin angle is basically a direct kind of indicator of how much force is going in the horizontal direction. I mean, if you draw like a vector along the shin and you kind of break it down into its horizontal and vertical components, it's just a direct, indicator of how much force is going in the horizontal direction. And so shin angle's obviously important as well. How you strike relative to your center of mass is a huge thing as well. That's why I added that component to the system. There's a part in the system where it basically actually annotates with drawings like where your center of mass is, where your foot strike position is, and show some vertical lines to show if how far behind your center of mass or in front of your center of mass you're striking. And I put that in there because I just think it's such an important concept. And I mean, if you just look at the statistics, you look at the data, I should say, of elite sprinters in these like biomechanical reports, for example, from some of the best accelerators in the world, from, the 60-meter world championship, I think in 2018 or something like this, they released biomechanical reports. It's just clear that, elite sprinters are really striking behind their center of mass. Of course, as you'd expect, they have very steep shin angles, as you expect. They show patterns, as you expect, with kind of gradual increase of shin angles. And I even did a video on my YouTube. It was a while ago now, but it kind of sort of shows Marcel Jacobs from, I think it was 2021, where he's really kind of falling into this trap that I think I fell into and a lot of other sprinters fall into, where they overemphasize this like forward lean. So I think that's how a lot of people phrase this kind of start of the sprint in terms of, or the drive phase is in terms of forward lean. Like that's usually the first thing people mention when they talk about accelerations. You want to lean forward. And people see elite sprinters do this and they try and mimic that, thinking that that's kind of the defining thing and the main goal. And of course, when you lean forward a lot, often you're going to overstride. It's going to basically force you to put your foot out too far in front of your center of mass. Otherwise, you're going to stumble forward. And there's this video of Marcel Jacobs, I think I found it on his Instagram from 2021, and he's just not accelerating very well at all. And he's leaning very far forward and it's not working well. And then I think a year or two later, his acceleration is much more focused on striking behind his center of mass with great shin angles. And he's actually fairly vertical. And I think it's a bit strange because Marcel Jacobs, when you look at his acceleration, I think it's a little bit distinct from other. He's a very good accelerator, despite having great like top end speed as well. But if you compare to other sprinters, he doesn't, at least to me, it doesn't look like he's got this really aggressive forward lean. If you compare him to like Coleman or Sue or someone like this. And I think that that's the right way to think about it. It's not really about the forward lean. It's like lean as far forward as you can whilst making sure you can also achieve these great foot strike positions and shin angles. Knowing that you're overstriding and analyzing that with the data, I think is a little bit different from actually making the changes needed to do that on an instinctive level, right? You can know that you're overstriding and like you should stop this. But then when you're actually sprinting, or if you're actually like coaching someone, having them internalize the right patterns and whatnot, I think is a bit of a separate task.
So, I mean, I think that there's a ton that you can definitely go into on that, just because I know a lot with my own experience of going down that path. It's very Because I can show you a couple like 40-yard dash sprints where the people are accelerating very well and definitely landing out in front of them themselves. And so it's one of those things where, and it gets back into the hip acceleration, in my opinion, it's a lot has to do with how well can you continue to move the hip in a certain, plane or direction, ends up being a big part of it, because, I've been trying to figure out I guess, kind of guideline to be able to go with when it comes to the combination of foot contact time and stride length. And as I'm sure everybody does, so it's like, in your first, a big thing that I try to tell people is like, first 4 steps, you want to be covering 5 yards. And so just as kind of a benchmark of something to be able to reach for. And then that first couple steps are trying to be about 0.17 seconds or under 0.17 seconds. But you see people that run, elite times that are not covering those, benchmarks. And then you see people that cover those benchmarks that don't have elite times. So it's one of those things where, it's a difficult kind of area to be able to get specific on. And I think it'd be great to be able to dive deeper into the data to really understand it at a higher level. But, like that ends up being such a big part of it is the acceleration. I was watching something that was talking about how a lot of these top sprinters get about 30% of their top speed within their first like 3 steps, which it just showcases how important those steps are. So getting the right data behind it and making it so you're doing it the right way is so important, because, going into your whole thing with the second step, I would argue there could be potential where, depending on your hip socket, there's got to be differences there, right? Because we see a lot of different types of like squatters, and it ends up being a very similar angular position in the squat as you're going through those first couple steps. And so, if there's different types of bar positions and depths and places that you get to when you're going through the squat, then there's undoubtedly different types of, subjective kind of positions that you'll want to get into based off of, different parts of your body or your hip socket or maybe your height. It's hard to know for sure which would be the main things, but I would argue that ends up being a big part of it. Like there's some people that are going to be able to land much more behind their center of mass or much more maybe under their center of mass because they have the hip position or the ankle range of motion maybe could be a big part of it as well, as opposed to somebody that might have a deeper hip angle and therefore not have as much range of dorsiflexion and then are landing more out in front of them with their foot contact, but can still accelerate at a very high level because they're able to get force from that position at a greater degree or, greater capability while landing in all these correct positions, quote unquote, correct positions. Well, I think that there's a lot of, potential to get into on that. When you see somebody do it correctly, you see like, I use Marcel Jacobs. He has a good behind view, and you can see how he's very pronated as he's striking the ground. And then, that allows him to be able to go into supination during the landing and then very cleanly transfer his weight forward as he's going into push off, as compared to a lot of athletes that will land more supinated, more on the outside part of the foot, then roll or fall in, and then they have to get back to the outside. And that's, in sprinting, as we know, it's hundreds of seconds, and it's those hundreds of seconds over and over and over again. You could be 200ths of a second slower and you apply that to 5 steps, and now you're way behind as opposed to, being able to get those steps at the right time, makes it so now you actually have a chance in a race or have a chance to be able to run a great 40 or a great 60s. It's definitely something that's very fascinating to me to be able to try to figure out, based off of what some of your anthropometrics are, what are the correct things to do in your sprinting pattern that make it so you run fast.
Yeah, I think there's a lot of room for like interpretation, how to kind of deal with all of this data now and the best way to interpret it and kind of extract new insights with respect to all the things that you're mentioning. Kind of, I think there's definitely a lot of room in this with this kind of technology coming out now that gives much more like fine-grained data. There's a lot of ways people can interpret that. It's going to be exciting to see kind of how people deal with that, or how coaches take that data and like come up with their own insights based off of that, for sure.
Yeah. I mean, do you want to give some I guess a bit of a rundown of the information and show us some of the stuff that you are able to, get and everything?
This is what the dashboard looks like. There's a bunch of different tabs here, but maybe I'll just go through kind of a report. So as I said, there's two different types of report. There's the light report and the full report. Maybe I'll just go through a full report that's going to contain everything that's available. But if you go to the website, you'll be able to find this page. There's a link to this report. You can click around and play around with it yourself. So basically, this is what like a report looks like. It's got kind of an overview of the sprint on the left, kind of an overall score, some scores for some specific aspects of the sprint, like explosivity. It's like based off max velocity, split times, center of mass displacement, basically just how fast you cover ground and all the stuff there. Technique is based off of shin angles, striking close to your center of mass, things like leg recovery. If you've got like this, like one thing I like to look at is the distance between the knees upon ground contact initiation. If you have like a huge distance between your knees, often going to be a sign that you're maybe striking a little bit too far, or that back leg isn't recovering fast enough. So I think that's also factored into the technique score. Forward lean and stuff like that. Elasticity is basically just ground contact times, comparing that to elite sprinters. Elite sprinters being like 100%. I mean, coaches don't necessarily have to use this. It's a nice shorthand I use to kind of like gauge where I'm at. Top speed and like 10-meter split. You can see here as well. This is basically what the video looks like. So I mentioned earlier how this like technology works is basically identifying the landmark positions at each frame of the video. They're basically overlaid on top of the athlete as they run. So these are the main landmarks that are used. Kind of, you can see the 3 points of each foot, the knees, hips, shoulders, stuff like that. And that's basically just the raw video that the user would have captured. So I just took this here on a tripod. And there's also this video, which is basically showing the instantaneous velocity of the center of mass throughout the sprint. It also has the split time here, and it also has the center of mass annotated on the video. So it's just like red dot here.
And how is that calculated, the center mass?
So the center of mass is calculated by basically taking kind of a standard portions of a regular person. It's not going to be 100% kind of specific to that person. So there is a little bit of room for error there, but I found that it's been quite accurate. I mean, even if you just take apart from the start where kind of the center of mass isn't even going to be on the body, it's going to be like a point outside of the body due to the way that the person is positioned. But during upright sprinting, like even if you just take the middle of the hips, that's usually a pretty good indicator. But instead of doing that, what we've done is basically taken the average model of the different mass of the different limbs of a person, of a standard person, for example, and then basically saying like, the leg is like 1 point whatever times the weight of this, and using those points and also using the calculated landmarks along with this kind of average values, you're able to calculate the point in space of the center of mass. So that's how that's calculated. If you really wanted to, you could do it like very specific. You could measure out all of this for an individual athlete, but I don't think that would be worth it. As I said, like just taking between the two hips even gives a pretty good estimate.
Yeah.
So
I was just curious.
Yeah, no, of course. So this basically just gives a split. It stops once you pass the 10-meter split line. And so this is just like the video analysis. I mean, this is interesting just to look at, but basically most of the analytics and whatnot are available through these tabs up here. So this is like the analytics tab, and you can look at some things here. The insights is basically just graphing each of the key metrics over each step. So you have ground contact times, for example. These are what I was talking about earlier, where if there's like some sort of potentially negative or positive, in the case of like one of these medals, as they're called, they're present, it kind of indicates some sort of technical issue there. Like you can see here between step 3 and 4, there's an increase in ground contact time. Step 4, I'm like maybe striking too far out in front of the body is potential. You can click on this and like read more. Again, this is more so for kind of individual athletes who might not have much background knowledge, or they would like some guidance. I've created these rules to basically automatically kind of detect these potential technical deficiencies by analyzing like things like this. They're basically just like guidelines to be like, hang on a sec, you've increased your ground contact time here during the first 7 steps or throughout this acceleration. Like that's not a good sign. Like maybe on this step, this is not a good foot strike position. Like you just spend a lot of time there compared to, for example, here, I'm kind of striking, at least looks to me, in a much more favorable position. Got good leg recovery, kind of striking, I would say roughly like under my center of mass. It just looks like a much nicer position. Whereas here, I could imagine that I'm introducing quite a lot of braking forces here. I'm definitely not going to be able to push for a while until kind of my center of mass moves quite a bit. But this is basically what these are. I mean, I'm sure if I go to another one, maybe like trunk angle to ground at touchdown. So here, I've got like this one, which is just like a positive indicator because my trunk angle is gradually increasing over the start. I mean, maybe late acceleration, not so great, but gradual increase over the first couple steps. Got this like kind of positive indicator here. So this is basically what these are, just all the different metrics. You can see them plotted out, and it has the respective image for the steps when you scroll through. So if I go to like a termination metric, like termination knee angles, it'll show the termination image for that. So it has the initiation angles and the termination angles for knee and shin and trunk as well.
Do you have hip too, or just knee, shin, and spine?
I don't have hip at the moment. But that could be easily added. I mean, it's important to know what people would use. If you think that hips are an important one, that people would certainly.
Yeah, I mean, I think it would be good to know what the foot strike was, because I almost feel like that would end up having the most amount of angular difference. For all those, I'd like to know the angular difference, but I think that the hip would probably have the greatest angular difference between initial contact and termination.
Right.
So, it would be interesting to be able to see, especially, when you look at it from a, one leg compared to the other leg, if you are going through 50 or 60 degrees of, extension on one side, but only 35 degrees on the other side, then it's a pretty good indicator of, a specific type of tightness. And another thing to even go into too, and I'm going through and trying to find, like the Dario report here, but one of the things that we would do as well through it would be able to get like a better predictor of injury, like based off of this information, you're a little bit more at risk to pull a groin, or a little bit more at risk to pull a hamstring. And that in itself could be just so unbelievably valuable for an athlete, to be able to have like a flag, like, hey, this is telling us like you might be at risk pulling your hamstring. You're not getting, too much knee extension and limited hip extension. Like this is not a good pattern for your bicep femoris or whatever.
Mm-hmm. Yeah, sure. I mean, any angle and whatnot that could be determined from those key kind of points of the person or the athlete throughout the sprint can be used to calculate any angle and things like that. So adding that would be a good idea. And also, it's interesting that you talk about asymmetry. There is kind of a point about asymmetry later on with the top speed report. So there's two different types of reports. Like this is the acceleration one, but there's also top speed available. And in the top speed, there's an additional kind of option to do asymmetry analysis between the left and right sides. So the reason it's not available for acceleration is because, of course, like the biomechanics of each step is going to be kind of unique, or you expect it to be unique. The first step compared to the second, whereas like top speed, you're expecting them to be kind of more homogeneous, right? Each step you'd expect it to be a bit more kind of biomechanically homogeneous. And so if you see like some asymmetries there, that might be, some sort of greater indicator of, weakness or technical issue or something like that.
Yeah, especially because like what you've been doing with or at least it seems like what you've been doing with the compilation of data is just being able to kind of get like an elite comparison I would even say too, and I don't know how much information you get at the beginning, but the more information you can kind of get about people will help being able to improve the quality of the data, because if you could get people that will say, I'm 6 foot, 180 pounds, and my, left foot is the foot that I have in front, then you can start to get a compilation of information, on your end to be able to say, okay, based off of some of this information that I'm getting, you can get a better technical analysis of what are some of the biggest problems in, 5 10 years, especially when you have more and more people and more and more information. It'll just make it so the data will probably just pop out information that you don't even need to like really look into. It's just like, oh wow, 6'1" people, and I start with their left foot have, like the force needs to be, or their hip, angles need to be this, or their shin ankles need to be this, or the big difference between people that are 6'3" and 5'8" in their, center of mass, and like all that information could just end up just being, right there in front of you. And it could be something that we, from a general perspective, just looking at it or just getting, whatever basic force data, we'll never be able to really see because it's impossible. There's only so many cases, only so many people I could work with. And even, with that, there's only so much I could remember from, somebody that's 5'10" in comparison to someone 6'3", that are, key differences. But if you have all that data just stored, then it could just be that much easier to be able to access and utilize.
Yeah, and I've been thinking about when you do these types of data analysis, like one of the methods that they use is like machine learning kind of analysis, where you don't have to kind of come up with your own kind of interpretations or rules of the data. Like, oh, we're going to be looking at this angle because that's indicative of like future hamstrings, or that's a predictor of future hamstring strains, or something like this. You don't really need to come up with your own rules to determine that. You basically just have a huge amount of data, and from that data, you're able to just extract insights without having to basically even really have much background information yourself. But the limitation of this approach is that you need a lot of data. It's not going to be that insightful if it's like, oh, elite sprinters have like lower ground contact times. But if you have something like, for example, like this, which is the location of each of the key points throughout the sprinting cycle, or for example, throughout an acceleration, and that, okay, this is from an elite sprinter, this is from a person who runs this time, this is a person from this height, this is a person that's had recurrent hamstring injuries. Just having that much fine-tuned data, knowing the exact position, gives you so much more data. And I think in the future, there's definitely going to be some sort of studies along the lines of this, where you're implementing these kind of machine learning approaches to data like this, and you have so much of it. Just in this one video, I have, thousands of data points to be able to extract out these insights that people haven't even thought about before. Like, oh, this angle or this particular metric has a strong correlation with hamstring injuries, or people that are really good over the first whatever steps tend to exhibit this quality and things like that. So absolutely, looking on like a more global scale in the future is a very exciting possibility. I think that's probably going to happen. I would imagine. I think it'd be very interesting. So anyway, yeah, these are basically all of the things here. There is this elite comparison. I mean, it is nice to be able to see kind of how the average elite athlete compares. Also, these individual athletes. This is just taken from the one I mentioned earlier, the biomechanical reports from the 60-meter World Indoor Championship. I think it's 2018 or something. And then you also have the velocity, instantaneous velocity graph. So you have the smooth velocity and also the raw velocity. And with the raw velocity, you can see more of that kind of typical pattern acceleration, deceleration over each step. I haven't looked into this, but it'd be interesting to see if people could actually like analyze this data, this kind of raw data, because I'm sure there's some sort of interesting things contained within the data, like how far, like if you're overstrutting or having like a bad foot strike position, maybe like the deceleration moments will be much more drastic compared to the acceleration moments or something like this. I mean, people just tend to smooth everything out, but maybe sometimes that can kind of, clean away some sort of insights that might be able to be gleaned from just looking at the raw data. So that's interesting. I haven't done anything there though, but that's that raw data is present. And you can download all of this, I think, from the data overview. So it just has some average values of the stride frequencies and whatnot, and you can download all of the raw velocity data, instantaneous smooth data, and all that type of stuff, and all of these metrics as well from the data overview. In the technique analysis tab, this is the one I was talking about earlier, where it takes like various metrics and kind of combines them together to try and form like a more holistic view of a certain kind of quality during acceleration in this case. So for example, foot strike. So it would take like ground contact time, shin angles. It would take distance to center of mass at touchdown, things like this, step velocities and whatnot. And it would kind of synthesize those to basically generate a small report that evaluates this quality, foot strike. So I think coaches might find it interesting, but I think it's more valuable for those individual athletes. But I still read them. I still kind of look at them. And I like looking at these images, as I mentioned earlier, which is basically the annotation of the foot strike position relative to the center of mass position at touchdown. It's kind of a rough representation, but it gives me kind of just a quick glance at what's happening at that particular point with respect to my foot strike position. And also up here, we have like step velocities plotted along with distance to center of mass at touchdown, which I think are two like really important qualities. Like I remember reading the biomechanics report, and I can't remember who the athlete was. One of the athletes had like a really big step on step 2, like in terms of their distance to center of mass at touchdown, it spiked. And on the subsequent step, their step velocity went down. Whereas the other athletes who were striking much, I mean, it makes intuitive sense, striking much more behind their center of mass, that had a lower or aligned with the center of mass, not such a positive value, had a huge increase, if I remember accurately. So looking at the interplay between step velocities and distance to center of mass at touchdown, I think is a useful thing to look at when you're evaluating foot strike position. So that's kind of there to show the interplay between those. If you have a high value here, you're probably going to see a decrease in step velocity is what I've kind of noticed there. And then you have the same thing for posture, which is basically how the trunk angle changes, and knee distance, which is what I was kind of mentioning before, looking at the distance between the knees at touchdown. I think that can be like another important quality that some people might find useful when analyzing whether we're like overstriding or whether our foot strike positions are good. Because even with the first step, sometimes I notice I'll be striking behind my center of mass and I'll have like a decent, at least in theory, first step, but I think the first step, it really needs to be much more aggressive, at least in my opinion. Like it can't just be, are you behind your center of mass or like aligned with your center of mass? I think it really needs to be kind of much behind, a lot behind, and with that second foot coming forward to be able to like ensure that you're getting your second foot down quickly. So looking at the knee distance here is, I think, quite valuable also for the second step. And later on, I remember I had the warning on the ground contact time graph earlier, warning here, and like it's kind of spiking here, the distance between the knees. So I know that's another thing that people like to look at, and I find it valuable. So I included that as kind of another quality that's analyzed. And then lastly, there's the kinogrammic analysis, which is basically just snapshots of the athlete as they progress through each step. It's got different representations. One is just the frame from the video. The other one is the kind of landmark skeletal representation of the position at that moment. And you can just scroll through the steps to basically look at that. I use this because you could go through the video and like, scroll and pause and whatnot, but I find it easier just to do this and kind of just look through through the positions I'm adopting like throughout the sprint cycle, just going through this instead. So those are basically the main things that are involved, that are provided through the report. As I said, all that data is available to download in CSV format raw here. And I know that coaches like to share their, visuals and results and whatnot with athletes, of course. So there's a possibility of just sharing this report. So if you want to share the report, you can have a link and you can just give that to anyone you want. They don't need an account. They don't need to be logged in or anything. And they can just open up the report themselves and view all of their, in the case of the athlete themselves, all of their data and the annotated images and anything that the coach wants to point out and show to the athlete. So yeah, that's basically an overview of what a report looks like.
Yeah, I mean, and then I guess real quickly, just for the people that are, I guess, interested, is from a cost perspective, what are people looking at when it comes to that?
Yeah, so from the cost perspective, At the moment, there's 3 different plans available. So basically, all of the plans allow you to generate as many unlimited reports as you want. Sorry, unlimited light reports as you want. So the light reports, maybe I can quickly show one of those. It's basically like this, but it doesn't have distance-based data. So if we go to light reports, go down here. I think this is the same one. This is slightly different. So this is like an example of a light report. It doesn't have the center of mass velocity calculations. It doesn't have the split time calculations, but it still has things like ground contact times, comparison to elite athletes, it had these technique reports and whatnot. So it's still valuable in that sense. So you can have at the moment, I mean, it might change in the future, kind of in the early release of the technology now. So at the moment, you can generate unlimited light reports at, I think the first plan is $25 a month for unlimited light reports. You can generate, I believe, 1 full report. So that's the one that we just looked at earlier, in addition to as many light reports as you want for $39 a month. I better get these right. So pretty sure it's $39 a month. And then the last one is $79 a month if you want to generate 5 full reports a month, as well as unlimited light reports. So that's how the pricing works there. I also mentioned that you get kind of force velocity profiling. If you want to generate a force velocity profile for an athlete using one of their full acceleration reports, and then you have to know their top speed. So just put some random result here. You can also generate force velocity profiles for athletes. That's also included from the middle plan, $39 a month. So if you're interested like that, you can go to the azideperformance.com website. You'll be able to see all of that there and explore the reports yourself if you want. As I said, you can share the reports easily. So I've just basically used the share link to allow people to have a look at some of my reports there as like a demonstration.
Yeah, that's great. I love it. Appreciate you taking the time here and going over all this stuff. I think there's a lot of obvious information here that we were able to, go over. And I think you talked about before the website that you can go to be able to find out where to purchase everything. I mean, is there a social media that you have that, people can follow that gives you more information about the products as well?
Yeah. So basically the name of the company is Azide Performance, and all of social media will be called Azide Performance. So if you just Google that or find that on YouTube or Instagram or anything like that, you'll be able to find it. But if you're interested in the sprint vision technology, you can just go to azideperformance.com/sprint -vision, and you'll be able to find that out there. Otherwise, you can contact me. It's contact@azideperformance.com if you want to email me a question or anything like that. So yeah, thanks for having me on, Morey, and it's been great talking about this.
Yeah, it's awesome. Thanks again.